welcome. The room is yours.
Okay, thank you very much for the introduction. 1 second that I share the screen. Thank you also for the invitation to this interesting webinar. I'm Corrado Moneta, Technical Sales Manager of ICMA San Giorgio. ICMA San Giorgio is a company that produces co-rotating twin screw extruder. The topic of my presentation of today is the analysis of the advanced recycling process using this technology that at the end has, you will see, is the ideal solution to approach a flexible advanced recycling process. This is the scheme of my presentation. Let's start with a brief introduction of the company. ICMA San Giorgio was founded in 1945 as a supporting company for the foundry owned by the Colombo family that are also owner of ICMA San Giorgio. And our experience and adventure in the plastic business started in 1965. And ICMA San Giorgio, starting from this year, produced the extrusion line based on the counter rotating twin screw extruder. But in 1986, our company decided to stop the production of counter rotating and move to the one of co-rotating because we understood the big potential of this solution if compared to the counter rotating solution. Co-rotating extruders are an incredible solution for extrusion and are widely used for a different kind of process like all the type of compounds, thermoplastic rubber, recycling, biopolymers, reactive extrusion, master batch, and so on. So starting from this year, our company started to accumulate experience in the use of this kind of technology. And I will skip all the other things happening in our company in the remaining here because I prefer to concentrate on other topics. But I want also to share with you some important information about us. First of all, our company is involved in the recycling plastic business for more than 30 years. So we have installed all around the world different extrusion lines to recycle polyolefins, to recycle polyamide, to recycle ABS polycarbonate, to recycle PVB, and so on. So we have a really huge experience in recycling. And also we receive several external high-level recognition for some projects that we developed. And like, for example, the solar impulse label that you can see here represented in this slide. Also, okay, we can return on this topic in the last slide of my presentation. I want also to underline that our company has also a strong scientific knowledge on the process inside the co-rotating twin screw extruder because we developed a lot of years ago a simulation software inside our company, and thanks to this experience, we learn a lot of very interesting scientific rules that influence the process in each step inside the screw. And using this knowledge, we also created, especially under the pressure of some of our customers, a technical lesson that we can offer to our customer in different modules according to their, let's say, specific interest. In our company, we have available a laboratory that in these last 2 years we also expanded and transferring a new building. Inside this laboratory, we can support customer or not customer that want to try something new, especially in recycling. We are well equipped, and is a key point for us in recycling to start from the laboratory because, you know, recycling means a lot of things. The material characteristics are not always the same. So in order to give a guarantee for us is a key point to start from our laboratory. It's clear so that our company produces co-rotating extruder, but we are also expert in providing turnkey projects based on this technology to produce all the different type of granules, but also to produce final products like sheet or foil. So at the end of the extruder, we install a die head, and after the head, we have a calendar and other equipment, all this designed inside our company. So we are also strongly expert in that extrusion processes. Let's move now to a brief introduction to the plastic recycling. When we speak about plastic recycling, we need to consider that is a really generic definition inside which we have a lot of different possibilities requested by the market. Starting from the simple regranulation of the recycled plastic, moving to additional requirement, more and more coming from the market to consider a compounding action in the process, or a blending, or the volatilization. Just to be clear with you, compounding means to mix inside the recycled plastic solid ingredients like additives or filler or fiber. Blending means to mix inside the recycled plastic additional polymers that can be originally present inside the recycled plastic, or they are added in order to modify the property of the original plastic. Blending means also to mix liquid additives. The volatilization is the section of the process where we reduce the volatiles content like VOC. Okay, so all these three additional steps in the recycling process define the advanced recycling. Advanced recycling is very interesting because it's able to provide a new life to a post-consumer waste that cannot be applied, cannot be used for anything. Okay, so we are able to modify the properties and the characteristic of the recycled plastic in order to achieve some characterization of the plastic, in order to use this plastic for different kind of application. So a company that is interested in advanced recycling needs to consider the installation of a proper extrusion solution that is able to have a good mixing performance, a good devolatilization performance, but also that is able to manage at the best the viscous dissipation inside the melt, in order to have under control the development of the temperature of the material, because this is another important point for the quality. The co-rotating extruder for sure represents an ideal candidate for this, because the efficiency of this extruder in processing polymers is incredible, but especially is also a flexible solution, like I will show you in the upcoming slides. So a brief introduction to the co-rotating extruder. That is important, especially for companies that are not familiar with this kind of technology. Co-rotating extruder is an extruder with two screws that are rotating in the same direction. And the interesting point is that it's designed with a model it has a modular design. Okay, so the screws and the barrel are not represented by one piece of steel, but they are composed by different sections. And the advantage is that for sure this kind of extruder can be easily reconfigured if it's needed, but especially gives us the possibility, that is very important, especially in recycling, to make a fine-tuning on the process. And I have an additional freedom to modify in the screw configuration, for example, to adjust the process in the recycling field. Also, it's very interesting, this modular design for the maintenance, because I will just substitute the screw elements and barrel section that are subjected to high wear or high corrosion. So I don't need to change the complete screw or the complete barrel. So easy maintenance and also lower cost of maintenance. The screw configuration is defined by a well-defined, let's say, sequence of screw elements taken by three families of elements, so the conveying elements, the kneading elements, and the mixing element. The definition of this sequence is very important, because this will influence a lot the efficiency of the process. Another interesting point of the co-rotating extruder is that it gives the possibility to feed the ingredient of the formulation in different positions along the axis of the extruder. The polymer, the recycled polymer, and additional polymer and additives can be fed at the beginning of the extruder. Fillers, fibers, additional polymers, or other additives that needs to be added after the melting of the main polymer can be fed into the extruder using one or more side feeders. Also, liquid additives can be fed using injectors. So as you can see, we have an unbelievable flexibility in managing the feeding of the ingredients of a formulation. Other very important point, especially for recycling, is the possibility to install, as you can see in this picture, more than one venting section. Venting sections are important to extract different kind of substances or volatilized contents, like first of all, the air that is introduced by low bulk density material, the moisture present in the recycled material, the volatile contaminants always present, and eventually also side products coming from a reaction that is happening inside the process. So let's move now to the concept of advanced recycling. Speaking about a process along a twin-screw extruder, we can divide the process in different steps that I'm showing you in these slides. It's very important to design the screw at the best to maximize the efficiency of each step in order to, starting from the recycled material, adding additives, for example, fillers, in order to achieve at the end a good quality final product. But to do this, I need to be sure that in each step of the process, I am transferring to the material the right amount of energy. Because if the energy transfer is too low, at the end, I will not complete all the section of the process, like, for example, melting or mixing. If the energy transfer is too high, there is a risk of degradation of the product. So it's very important to fine-tune the screw configuration at the best to have the right final quality. And with the rotating extruder, it's very easy, because with a modular design, it's easy to change a little bit something in order to fine-tune the energy transfer to the product. So for advanced recycling, it's important to take care of these three important subjects. Let's start from mixing. Mixing is important because it gives us the possibility to have a good uniform composition in the final product, and also a good dispersion of the final ingredient included in the formulation. Considering a recycling process, we need to take care of the contamination inside the recycled material. Contamination that can be solid, and they can be so well mixed inside the product or extracted from the process using a special designed filter installed at the end of the extruder. We have also polymer contamination, and if they have a melting temperature compatible with the process temperature of the process, temperature of the process that we are taking care, at the end they are melted, and they need to be well dispersed and distributed in the main plastic matrix, obtaining a good dispersion and so a morphology like the one that are shown in this picture. In the advanced recycling, in addition to contamination, we have also to mix at the best additional ingredients that we are feeding to modify the characteristic of the base polymer, like peroxide, additives, rubber, filler, fiber. So all of them needs to be well mixed. And to do this, we need to apply and we need to generate along the screw high shear and elongational section. And this is easily accomplished, including kneading elements or a mixing element in different positions. And thanks to the high stresses that are transferred to the material in this mixing section, it's possible to reduce at the best the agglomerate size and also the droplets of the different polymers included in the process at the right size to, at the end, achieve a good final product quality, because this is very important. So starting from a situation like this, where the products is not well mixed, moving through the two typical type of the mixing, we reach the final ideal situation of a well mixed product. And to do this, you need for sure to have a mixing machine, so an extruder that is able to provide a good mixing efficiency. Okay. Mixing is also important to guarantee the final product a thermal uniformity, because if I don't have this kind of uniformity, the characteristics of the final product are not constant, and this is not good. Here we can see a transversal section of a screw that is stretched for sure to enhance the different thermal region inside the screw channel. And if I'm not able to erase this thermal gradient, the final product will be not good. And so the good requirements for the general requirements for a good mixing are the following. So a continuous flow reorientation, the presence of an elongational flow that is easily generated by needing elements available in the co-rotating extruder, high shear level section in the screw, and also is important to have the right residence time of the material in those mixing sections if I want to accomplish a good mixing at the end. It's not enough to have high shear level or elongational level. Also, the residence time needs to be high enough. Very important. All these kind of requirements are easily supported by the co-rotating extruder thanks to its modular design, but also another advantage is that we have the possibility to play with the screw speed. It's not like some kind of extruder that are working with the main hopper full of material, so where I cannot change the screw speed because otherwise I will change the capacity. The co-rotating extruder is working in a starved feed mode. This means that the main hopper is empty, so I can play with the screw speed in order to adjust the efficiency of different process sections without compromising the capacity of the extruder. Moving to the venting section of the process, another very important section because is responsible for the quality of the final product. In this section, we are removing the volatile ice from the process in order to achieve a good final quality and also to respect health and environmental requirements and to reduce or erase the smells from the plastic. The general requirement for a good devolatilization performance are to have a low screw filling ratio in this section, a good melt temperature in order to maximize at the best the mass transfer of volatiles from the polymer, to have again a good enough residence time in order to enhance at the best the efficiency of this section, and also to have a good melt layers renewal. So layers renewal to be exposed to the vacuum action, and the possibility to install more than one venting point in order to extract high percentage of volatiles from the process. Again, the co-rotating twin screw extruder, for the reason already explained in the previous slide, is able to easily manage all those requirements. I want to add again the capability to adjust at the best the temperature of the melt. That is a key point for the efficiency of the volatilization process. The venting process can be defined, let's say, in three different steps. The first step is the mass transfer of volatiles to the polymer vapor interface. At that interface, the volatiles evaporates, and then they are extracted through the vacuum section. We have available two main mass transfer mechanisms in the extruder. The first one is the molecular diffusion of the volatiles through the polymer. The second one is the mass foaming. The first one is not so interesting because the molecular diffusion of volatiles inside the polymer is really poor. Okay, so we cannot concentrate on this kind of mechanism. It's better to concentrate on the second one. And mass foaming is happening because we have a lot of bubbles inside the melt, and the bubbles population is generated more and more, fixing the right screw speed and melt temperature. Okay, and those bubbles are attracting inside them the volatiles. Okay, and those bubbles are expanding and reaching the surface. They break up, realizing the content. Okay, this is the mass foaming mechanism, and this is the one that I need to concentrate on in order to maximize the efficiency of the devolatilization. The advantage of co-rotating twin extruder in devolatilization are that they have an higher exposed surface to the vacuum because we have two screws and not just one. It's easy to install more than one venting section. It is essential for recycling. We can fine-tune the residence time in the venting section, and also we can easily control the filling ratio of the material inside the screw. That is another very important key point because having a max expansion inside the extruder, I need to have a lot of free volume available to promote this mass expansion. The screw speed is also another important topic, because increasing the screw speed, I can increase the frequency of melt renewal in the vacuum section, another important parameter to play with. To be noted is that more and more I'm extracting volatiles from the polymer, more and more the efficiency of the mass transfer is reducing, until we reach a limit that then will stop completely the volatilization performance. And so at the end, in my final product, I will have some residual content of volatiles. If it's acceptable, fantastic. But if it's not acceptable, in order to proceed in the reduction of those volatiles, we need to consider the approach with stripping agent that can be injected in the process. And these stripping agents are increasing the bubbles population, and so they are increasing the effective surface available for the mass transfer. The traditional stripping agent used are water, nitrogen, and CO2. Another important point, already mentioned more than one time during my presentation, that can be managed easily in the rotating extruder is the temperature of the melt. So we need to control the temperature of the melt, first of all, in order to increase the efficiency of different sections of the process, like mixing and venting. But it's also very important for the final quality of the product. If the product is overheated, the quality will be not good enough in some situation. And the rotating extruder is able really to provide the right amount of energy and when it's needed. And this is a big advantage, because especially with recycled material, the rheological characterization of the recycled material is not constant like when we play with virgin material. So we need to have a flexible extrusion solution that can adapt the process to the rheology variation of the product. You see here a calculation of the temperature development according to 3 different rheology. You can see from the blue one to the black one how the final temperature of the product is changing. So it's important to have, I insist, a extrusion solution that can adjust the process in order to avoid overheating of the final product. To conclude my presentation, let's see some recent development of our company. We develop a special force feeding system that is also a patent that give us the possibility to manage easily low bulk density material, typically coming from the lightweight packaging after the washing line. And thanks to this new development, we are able to feed easily inside the extruder this material, so improving the intake capability of the extruder, and so improving the capacity of the extruder. This increase of capacity is clear from the original bulk density of the material. The advantage to use this solution is that we can avoid to apply on the extruder the big compactor, the compacting unit that you can find on single screw extruder, that first of all, they are consuming energy. So with this solution, we are able to lower the energy consumption, and also this can provide a constant quantity of material to the extruder. It is something that is not happening with the big compactor of single screw extruders. According also to comment that we collected from our customers that are using this solution. Another development that we considered this year was the use of stripping agent, but not in a traditional way, but developing a process with multiple injection of stripping agent. And this was done under the pressure of our customer that wanted to reduce at the best the VOC content in the final product coming out from the extruder. And the critical step of the process that we needed to manage was the proper dosing of the stripping agent, the proper mixing of the agent, and especially a proper decompression of the mixture before coming in the volatilization section. The result was unbelievable. We were able to reduce a lot the VOC level in the final product, and the reduction is also strictly related to the specific chemical composite that you want to take in consideration. The last development that I want to show you is a direct extrusion line to produce a 3-layer board starting from post-consumer recycled plastic. And this board is substituting plywood board that are normally used in the construction industry. This 3-layer board has a central layer that is foam in order to reduce the weight of the panel and also to simplify its management. This is the picture of the product. You see the central layer that is foamed. I finished my presentation with this slide that I don't want to explain because otherwise it will take a lot of time. In any case, this shows how much ICMA is involved in a circular economy. First of all, as already mentioned at the beginning, we are for more than 30 years involved in recycling. And also we receive a lot of external high-level recognition that I here listed. So we are sure to be the ideal partner for any company that wants to start the adventure in this, let's say, advanced recycling business. Thank you very much for your attention, and I am available for any question. Thank you.